All right, we are starting with number one. Number one, they gave us a question which says a boy of mass 40 kilograms. So we have a boy has a mass of 40 kilograms, walks up a flight of 12 steps. Alinda, please mute your microphone or else I'm going to send you out of this meeting.
Yes, so could you muting?
I've said leave your microphones muted or else I will send you away from the meeting. Why do you have to keep on unmuting when you have nothing to say? I'm going to send most of you in the waiting room. I want us to listen so that we can learn something. We have a boy of mass 40 kilograms walks up a flight of 12 steps. So if maybe you have staircases or stairs that are 12 and each step is for 20 centimeters high. So we are asking us to calculate the work done by the boy in climbing up the stairs. My friends, please keep your microphones muted. This is the last warning. Otherwise, I'm going to start putting you in the waiting rooms.
Mute.
Mute, if they say mute.
Okay. I will first stop sharing that and I then share a whiteboard. Now they gave us a question in which we have the mass M, in which we have the mass M as equal to 40 kilograms. So the mass M is 40 kilograms. After giving us the mass, they gave us that we have 12 steps, as each step has a height h, which is equal to 20 centimeters. And they are asking us for work done. Now, remember, we said that if work is done when, let us say these are the steps. These are the steps, they are 12. Like that. So what we want is to move from the ground here up to up here. Use another color. So we want to move from the ground here to up here, but we are going to use stairs. Now there are 12 steps and each step has a height of 20 centimeters. That means that the height you are going to climb will be 12 times 20. So the total height that we are going to climb as we go up in centimeters Now, you people, how do you expect me to use this screen which you are doing like this? because I want us to discuss well, but now you see what you are doing to my screen. Everyone wants to do everything that you want. Okay. Now I was telling you that the height that we are going to move from down here to up is going to be 12 times 20, which is 240. Now 240 are centimeters, and I request you change them to meters. So if we are to change them to meters, we divide through by 100. And if we divide through by 100, we find out that our height that we are going to move going up is going to be equal to 2.4 meters. Now, these 2.4 meters is like the distance that you are going to move from down to up. Remember, they asked us for work done. If you remember what they told us, what we studied during the first lesson, we said that we get work done. We said we get work done from force or weight times the distance moved. The distance moved. In case of moving up, we say times the height. Times the height. So that means that in this case, our work done will be equal to force. Now force, we said to get force or to get weight, we get it from mass times acceleration due to gravity. The mass in kilograms times acceleration due to gravity gives us the weight or gives us the force. Now, acceleration due to gravity is a constant, and on our work, they told us to use the constant G as 10. That means that if I'm to get the work done here, I'm going to use my mass as 40 kilograms. I multiply by 10, which is the acceleration due to gravity. So in other words, that one that I've got is the weight. Then after getting that weight, I multiply with my distance h, which is 2.4. And the answer that we get will be in, so 40 times 10 times 2.4, we get our answer as I think the answer will be 96. I've calculated well. The answer that we get there will be 96. And we said work done is in joules. So that will be our answer. That is if we have calculated well. 960. Oh, it is 900. Yeah, it's 960 joules. I had made a mistake somewhere here. So it's 960 joules. Yes, Esther, your hand is up. You unmute. Esther?
Okay, teacher, I'm not understanding. Please repeat.
What are you not understanding?
I was just asking you to repeat the explanation for the answer of number 1, the whole of it.
Okay, are you there in our first lesson?
Yes.
And in the second one?
Okay,
Okay.
I was there, but network issue.
Okay, fine. And then Joyce. Joyce, what are you? Your hand is up. You ask what you want to ask so that it's possible I can answer it.
So I was just asking, how did you get 10?
10 was given to us. 10 is a constant called acceleration due to gravity. So for it, it doesn't change. So long as they ask you acceleration due to gravity, we take it as 10. So that one is given to us. You will see in our document, which I will share after explaining Esther's thing. You will see it was given to us there. Yes, this.
Thank you, sir.
You see why your hand is up?
So what does acceleration due to gravity mean?
Okay, fine. I will answer that also. Okay, I'm answering Esther first. She asked me to explain for her again what I have written here. Yes, to explain for you, Esther, we start with the question. They gave us a man of mass 40 kilograms moving up a staircase of 12 steps and each having a height of 20 centimeters. And they asked us for the work done. In our first lesson, we defined work done as the product of force and distance moved in the direction of force. And that force is the same as weight. And sometimes the distance moved can be vertical. Vertical means from up to down. And instead of calling it distance moved, we call it a height. So we can call it a height. Now, if a person moves stairs, upstairs, 12 stairs, and each stair has each stair having 20 centimeters, that means the first thing that we should find out is what distance has that person moved from the beginning to the end of those 12 stairs. That is what we have done here by getting the 12 stairs and multiplying them with the height that each stair has. So it is 12 times 20, which gave us 240. But they were 240 centimeters, and we had to change them to meters. Why do we change to meters? Because the distance, if we are to use the formula for work done, must be in meters for the work to be in joules. That's why we changed here to meters, and we got our total height for all the 12 steps as 2.4 meters. So we came back here to our answer, and we said that our work done is the force And force, I told you, is the same as mass times acceleration due to gravity. Now, someone asked me, what does acceleration due to gravity mean? It means what does acceleration due to gravity mean? Now, when a body is thrown upwards, for example, you get a stone and throw up, it comes back down because of a force called a gravitational force. Now, the way it comes up, what forces it to come is the gravitational force. And that force changes the speed of that stone at a rate of 10 meters per second squared. It changes the speed of that stone as it comes downwards by 10 meters per second. That means that that stone, as it comes down, it moves 10 meters in every second, 10 meters in every second squared. The change in its velocity is 10 meters per second squared. Now, that is what we call acceleration. How the velocity of a body changes in every second as it is acted on by a gravitational force. Now, that is what we call acceleration due to gravity. And the acceleration due to gravity is constant. Constant means it's the same for all bodies, and it is 10 meters per second. Now, if a body is going up or coming down, we consider the force as its weight, and weight is got from its mass times the 10. 10 is always given to us as acceleration due to gravity. That's why here I multiplied the mass, which is 40, times 10. So this one here is weight of force, then times the height of all the stairs, the 2.4 that they gave us here. And we got 960 joules as our answer for number 1. Now, there are friends of mine who are still asking me, which topic is that? If you have always been here from our first lesson, you know that we are doing work, power, and energy, and the subject is physics. If this is your first lesson, I'm sorry, you just have to listen carefully, and the documents for the first lesson, second lesson, and this lesson are going to be in the group after this lesson has ended. Okay, that was our number 1 for my friends who tried it out, and I'm sure you got that answer of 960 joules, and you have seen how we have got it. Now let us go to number 2. Let us continue with number 2. Number 2 tells us that we have an electric motor which raises a mass or a load of 50 kilograms. So the load is 50 kilograms at a constant velocity. They're asking us to calculate the power of the motor if it takes 40 seconds to raise the load through a height of 24 meters. Height is 24 meters, time is 40 seconds, and mass is 50 kilograms. Okay, now for this number, they have told us to calculate the power it takes to raise 40. We have power We have time, we have height, we have mass. Okay. So now for that specific question, they have given us the mass M as 50 kilograms. They have given us time. It takes that motor to carry that load. The time is 40 seconds. And then there is a height H, which is 24 meters. And they are asking us for power. For my friends who were there in our first lesson, we defined power as work, the rate of doing work. And we said that work done power can be got from work done divided by the time taken. So I'm going to use so it is work done out of the time taken. Sorry. So it is work done out of time taken. Now, from what we have, you realize that work done can be got from this mass. Remember, whenever they give us mass in kilograms, we have to change it to weight. So the work done will be the mass, which is 50, times acceleration due to gravity G. So this one gives us the force. Remember, work done is force times distance. So our distance is the 24 meters. So we'll be having 24 there as our height. Then out of the time that is taken to do that work, so the time that they gave us is 40 seconds. So that means that our, to continue there, our mass is 50 kilograms. G is the acceleration due to gravity, which is 10, and then times 24, which is the distance. So up we have work done. Then down here, if we divide by 40, is the total time taken. Now, if you calculate, you will be having 500 times 24, then divide by 40. 50 is the mass, 10 is the acceleration due to gravity, which is 10 meters per second squared. Then 24 is the height or distance moved, and 40 is the time taken. So if you calculate, which answer do we get? 500 times that, we get our answer here as we get our answer as 300, and that 300 is in watts. Remember, we said that the SI unit for units for power are watts. So the answer is 300 watts. That is our answer for question number 2. If there is any question there, you ask now, because I want us to go to number 3. You raise up your hand and ask, or you write your question in the chat in case of any question. If there is no question, then we go to number 3. Yes, Joshua, your hand is up. Joshua? Okay, maybe there is no question. Let us go to number 3. Number 3 is asking us that at what average velocity can a motor rated 200 watts raise a load of 40 kilograms? At what velocity? So you pay attention, because we may have missed this when we are doing our notes, but it is easy if you pay attention. Now, someone may ask, what is velocity? Can I have some answers in the chat? If someone asks us for velocity. For those people asking where 10 is coming from, where is 10 coming from? The answer is there. At the beginning of this exercise, they told us, where necessary, take acceleration due to gravity as 10 meters per second squared. So that is where it comes from. Whenever I need it, I just use it because it's a constant. What you have to do is to go back in your books where you studied forces. I'm sure your teachers at school taught you what acceleration due to gravity is all about. That is what you have to do. As someone is telling me velocity is speed of something in a given direction, yes. Speed used when doing work, that is velocity. Any other answers in the chat about velocity? I think velocity is a speed, yes. Then for my friends who are sharing contacts in the chat, please stop. It's very dangerous. We don't know which people we are dealing with in here. So please don't send anything like your contact, email or phone number in the chat. If you want to speak to someone and you know that someone lets you talk out of the chat, please. Letitia is telling me that it's the rate of change of displacement. Yes. All right. We have an idea of velocity, and I'm going to make that idea clearer here. Now, if someone talks about velocity, let me call it that. If someone talks about velocity, that person is talking about how distance or how displacement is changing with time. In other words, velocity is the same as speed. The only difference is that velocity is speed in a specified direction. That is the difference. So we all know that if I want to get speed, I get it from distance divided by time. That is how I get velocity. distance divided by time. Now, according to our question, they have given us power. Power, let me call it P. And we know that power is work done, and work done is force times distance, then out of time. Now, if you look at this one well, you see that our power P can be written as F times. Now, since this T is all over, we can also put it here, D out of T. Now you see that this D out of T, D is distance and T is the time, which takes us to velocity. So you will see that here power is equal to force times the velocity. Remember, they have given us power as 200 watts. They have given us mass as 40 kilograms. That means we can get force. You know, F, mass, force is, we told you, is mass times acceleration due to gravity, which is 10. So that means our F is going to be equal to the 40, which is the mass, times the G, which is 10. That is acceleration due to gravity. And then all times V, which is our velocity, sorry. Times V, which is our velocity. So you realize that our 200, in that sense, is equal to 400 V. So if you divide through by 400 on both sides, to make V the subject or to remain with V alone on each side, our answer for V will be equal to, our V will be equal to, so which answer will you get for V? Which answer are we getting for V? 200 out of 400. So the answer is a half, which is 0.5, and 0.5 or a half is velocity, which is in meters per second. People's hands are up. Trying to see those people whose hands are up. Yes, Patricia. Patricia?
Yes, sir. Okay. I don't know where that acceleration due to gravity again came from, because here I've put power is equals to force times distance.
But I told you force is mass times acceleration due to gravity. And they have given us mass, not force.
Okay, so does it mean whenever we're calculating power and power is equals to force times distance, we just put the force as the mg, mass and acceleration?
Mass times acceleration due to gravity.
Okay, thank you.
All right. Yes, Ryan. 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 Yes, Van, your hand is up.
Okay, so for me, I'm confused. Like, where did the power start being the same as 40 times 10 into, like, how did it come? Because power is equals to force times.
Okay, I've got your question. All right. I want you to look closely here, Van, where they gave us, we started with this. I started with asking people what they know about velocity. And we had it that velocity can be got from distance over time. That is where we started. Our question gave us power and mass, and it was asking us for the average velocity. So for us to get the average velocity, we had to find a way of getting velocity from the definition of power that we know, because the definition of power is work done divided by time taken. So work done is force and distance, then divide by t. So that is where we started from. So we came here, down here, and we separated them, where we had force times distance over time. We put the time only on D, because if you know about multiplication of fractions, F is the same as F out of 1. So multiplying the 2 will take us back to what we have there. So now we had, instead of having my power as force times distance over time, now I put distance and time together so that I can bring out the velocity. Velocity is distance divided by time, which is here, d out of t. So that d out of t is the one that has taken me here, where we are having our power is equal to force, where force is mass times acceleration due to gravity, times v, velocity, which is distance divided by time. So that is what I first had. After knowing that my velocity that I don't have, but they have asked for it, can be got from this expression, then I put in what I had. I put in 200 because 200 is the power. Then 40 is my mass and 10 is the acceleration due to gravity. So those two give me the force. And then I get my velocity that they asked for as 0.5 meters per second. I think I've explained to you all well where I got the G, acceleration due to gravity, force over time gives us speed or gives us velocity, and it's the velocity they asked for. Okay, that is number 3. I want us to continue with maybe number 4. Then I will leave you to try some numbers for you. We have number 4. Number 4 tells us of the following. Number 4, we have an object of mass 2.5 kilograms. It is released from a height of 5 meters above the ground. Then they are asking us to calculate the velocity of the object just before it strikes the ground. Just before it strikes the ground. Now they have asked us for the velocity, and they are telling us that what assumptions have you made in your calculations? Now I think there are some people who are not following. They just want to see answers coming in, and after the answers have come, they ask, where have you got the answer, without following. Now I want us to follow from the question. Whenever they give you a calculation question, the first thing that you should do is to summarize out the things that they have given you. And then you will find out how do they relate to what you want to get. And where are you going to pass? For example, here they have given us the mass of the object and the height at which it is on. And they have asked us for the velocity. Now, what do you know? When we are studying work, power, and energy, that is in the last week, the lesson that we had last week, we talked about energy. And in energy, we talked about some types of energy or the forms of energy. And in those forms of energy, there is that we called kinetic energy. And there is that one that we called potential energy. Now, if there are some people who still remember what we said, anyone who can define for us potential energy and the other one kinetic energy, you can raise up your hands if you remember what we discussed. Yes, Esther?
I'm defining kinetic energy.
Yes.
This is the energy possessed by a body in motion.
Yes, kinetic energy is possessed by a body in motion. How do we get kinetic energy, Esther, before you go off?
Kinetic energy is equal to a half of mass of a body times the velocity squared. Okay, thank you so much, Esther. Then Ariana, you give me the answer for, Ariana has run away. Okay, Ariana has run away. Nicholas, you give me the potential energy. Nicholas?
Potential energy is the form of energy possessed by a body when it's above the ground.
Okay, energy possessed by a body due to its position above the ground. Then after talking about those ones, can someone remind me what we said about energy forms? the principle of conservation of energy. Principle of conservation of energy. Yes, Van, your hand is still up. Van.
The law of conservation of, wait.
Yes.
Bundi, sir, repeat the question.
I want that principle of conservation of energy. What did we say about it? Forgotten.
Which makes energy useful in the law of conservation. They have stated that.
All right, Elizabeth. People raise up their hands and then they run away. Okay, Bridget, you give me the answer.
The principle of conservation of energy states that energy is neither created nor destroyed, but can be transformed from one form to another.
Okay, thank you so much, Bridget. Now, we have talked about three things. One, kinetic energy. The other is potential energy. Then the other is energy being transformed from one form to another. Now we have a body which is up here and then it falls to the ground. They are asking for which velocity, with which velocity does it fall to the ground? Now when it's up here, it has potential energy. And that potential energy, we have seen that can be calculated from m, which is mass, times g, which is acceleration due to gravity, times h, which is height from the ground. Whereas when it falls, it is moving. So as it falls down, before it knocks the ground, all the potential energy has been converted to kinetic energy. Now that is the assumption that we are going to make, that all potential energy as this body falls to the ground has been converted to kinetic energy. So potential energy, kinetic energy, remember it's a half times mass times the V squared. Now, when we have got all that, how do we calculate? Remember, they only give us the mass and the height, and we know that G is 10, the acceleration due to gravity. So this is what we do. Our mass, we have said all potential energy, all the potential energy has been converted. So potential energy lost, I'm going to write it in this form, that the potential energy that is lost is going to be equal to the kinetic energy. It's going to be equal to the kinetic energy that has been gained. So all the potential energy will be lost to form kinetic energy. That is from the principle of conservation of energy. So here we have our mass as 2.5 kilograms times the acceleration due to gravity, which is 10, then times the height that they gave us, which is 5 meters. All this has been converted to, now this side we have a half, this side we have a half, which is 1 out of 2, times m, which is mass. So our mass, remember, it is 2.5. 2.5, then times velocity squared. Remember, we don't have the velocity. It is the one that they want us to find. So what you're going to do is to get for me the answer for this side, which is 2.5 times 10 times 5 will be equal to Now a half of 2.5, I think it's 1.25. 25, then v squared. So you tell me what we have this way. 25 times 2.5 times 10 times 5. Someone has already given me the answer. The answer is 125. So since we want to get V, we are going to divide by 1.25 on both sides, 1.25 this side, and 1.25 also this side. So this one will go with this. And what will we have as our V squared? If you have a calculator, what will our V squared be equal to? Our V squared will be equal to, Nicholas has told me, it will be equal to 100. Nicholas has told me it's equal to 100. Okay, 100. So since we want V, we will get square root on both sides. And getting a square root on both sides, we'll be having our V as, our V will be equal to square root of 100 is 10. So our answer for velocity will be 10 meters per second. 10 meters per second. That will be our velocity. Okay. So that is our question number 4. Yes. That is our answer.
She's not complaining. She was our director of studies, and now she's a
Excuse me, teacher. On that number 4, which we are just doing, I have not understood very well that last part where we got over the kinetic, over the potential energy equaling the kinetic, something like that. I have not got it very, very well.
Okay, Hannah, we are going to go back to this one here. If I've got your question well. Now, you asked how we got potential energy equal to kinetic. I'm taking you back to what we discussed first. We discussed that the principle of conservation of energy says that energy can neither be created nor destroyed, but only changes from one form to another. Now, for a body which is up here, it possesses potential energy, which is mgh. When it comes down, it starts moving. When it's coming down, it moves. And before it hits the ground, it possesses maximum kinetic energy. What does that mean? It means that all the potential energy this body had has been converted to kinetic energy, because the velocity with which it hits the ground, it means that it has its height now at 0. That means that all potential energy has been lost to kinetic energy. So that's why I've written here that all the potential energy lost is equal to kinetic energy gained. And that is where I've got that answer from. Hope you have got it anyway. What is the difference between potential energy and kinetic energy? We have even told you in the definitions. Potential energy is energy possessed by a body due to its position above the ground, whereas kinetic energy is that one possessed by a body that is moving. So that is it. Let us try number 5, number 6, and number 7, maybe, and 8, so that we can get our other answers. Number 5, number 6, number 7, and 8. So you try them out. I think now you have the idea of the calculations. You can come up with the answer as well. Okay, now for today, I'm going to stop here. We are going to have this document sent in your group so that you can try out those numbers at your pace, such that in our next lesson, maybe, or if you can send a message, you can ask any question that comes up as you try those numbers. I think we will try up to number, okay, up to the last number, but in your time. So the rest of the numbers are going to be as your homework for today. I'm going to send them in your groups. Otherwise, have a good time. Maybe someone to pray for us before we go. Yes, Patricia. Patricia.
Let's humble ourselves and we pray. Almighty God, thank you for today. Thank you for the gift of life. Thank you for this lesson. Thank you for our teacher who has endeavored to explain for us the work. I want to pray that as we are leaving it, even for the assignment we have, that you help us to answer it and read the question carefully and understand it so that we give the right answers. In Jesus' name I've prayed and believed. Amen.